Just like the Monday class,
What's that? Nah, whatever is done on the Sunday classes, I'm not going to reteach it. That's why we invite everybody from the Monday class, both morning and evening, from the Wednesday class, as well as the Saturday class, to come on board. Because whatever is done on the Sunday, I'm not going to be redoing it, because the Sunday class is like a makeup class for everybody. And this is necessary for us to finish the syllabus on time. Although we have an extension with respect to the date, I want to make sure that we are finished with the syllabus. So with the extra time that we get, we will take that time and use it to perfect our multiple choice skills, as well as our paper 2 skills, because like I said in last week's Sunday's class, we are not sure if they will take paper 2 questions or paper 2 structured question, those type of questions, and convert them to a multiple choice. Hence the reason it's of paramount importance that you all do not only focus on multiple choice papers, but you focus on paper 2 as well, because that's where your requisite knowledge will come in, not with the multiple choice. The multiple choice is just recalling the information. And I mean, come on, everybody knows that everybody is at home right now. CXC knows that everybody's at home right now. Everybody, school is out as well, so everybody will have more time to practice. So of course, they're not gonna just bring a easy multiple choice exam for you all, okay? It's gonna have, I personally think that it's gonna have some kind of technical thing in it. I don't think it's gonna be like a normal multiple choice. If it does come like a normal multiple choice, well, great. But I highly doubt that they will bring a normal multiple choice question. I mean, normal multiple choice paper. I think it's gonna have like paper 2 type questions in it, and the answers are going to be like multiple choice. I personally think so. And I'm not sure if it's gonna be an online multiple choice exam. If it is, well, you will have the advantage of being in the comfort of your home and doing the multiple choice exam. And of course, you know that in multiple choice, you're not allowed to use a calculator. I'm not encouraging you all to be dishonest, but I mean, if you're at home, the chances of you passing is even better, because they would not know if you have your books out. They will not know if you have your calculators out. But I mean, at the end of the day, it's up to you and your honesty to be, to do the right thing and not cheat.
So you need to trim out apart from the recalling.
No, I'm not encouraging you all to cheat. I'm just telling you all that there is a high possibility of that, and they will take into consideration all of those things. So I don't think the exam is going to be as easy as everybody thinks it's going to be. And I think that's why a lot of people are also skipping this class, because they are of the opinion that they could just study the multiple choice questions and it's just to memorize the answers and they will pass the exam. And I think that's where they're going to fall short. Because
like set up a camera to watch and thing when you're doing the exam, something like that.
I have no idea what they're going to do, because I'm not sure. Well, I've never witnessed an online exam for CXC. I know they were trying to do it last year, and I think the year before they were trying something, but I'm not sure how that will be. But I can safely tell you all that it's not going to be as easy as you all think it's going to be. And that's the misconception that a lot of students have, that the exam is going to be just a multiple choice exam and they're going to wing it and pass it. And they're just going to practice with some multiple choice past papers and they're going to do extremely well. I don't think that CXC is going to make it that easy for you all, right? Because at the end of the day, CXC is an examining body, and the goal of it is to test the students who are actually studying and give the grade 1s to the students who are actually studying, not just giving out grade 1s like Oprah giveaway cars, right? So I think they're going to have some level of difficulty with respect to the exam. And like I said, I know there is the possibility of, if you all are doing the exam at home, that you all will be able to use your calculators and your textbooks and whatnot to kind of more or less cheat. So I think that they're going to have to take into consideration all of those factors. And as a result, the exam, as I said, it's not going to be as easy as you all think it's going to be. You know, I think they might have something on the screen where you could lock the screen, or I'm not sure how they will have it. But like I said, it's going to have students who are wanting to cheat. And I can only tell you all to do the right thing. Don't cheat, you know, because the length of time you will take to cheat, searching in the textbook for this note and that note, you could have it in your head and you just easily write it down or type it out or, you know, do your stuff, right? So I'm not encouraging anybody to cheat. Cheating is not right. But again, at the end of the day, you need to know what is right from wrong. Yeah, so I'm encouraging you all to study your work and practice, because at the end of the day, you do not know how the exam is going to come, you know? So please, do the right thing, okay? Anyway, so let's. What's that?
They might make it face cam.
All that too, you know? There is all of that possibility. So let's get started with today's lesson with vectors. So I'm going to try to finish the entire vectors, and if there is a possibility that we can do past papers today, then we'll do the past papers today. If not, we will do the past papers in your respective classes. So the Monday classes, we will do the past papers in the Monday class. The Wednesday class, we will do the past papers in the Wednesday class, and the Saturday class, we will do the past papers in the Saturday class, right? And of course, the homework that I gave you all with matrices and relations and functions, that one question, I will also correct that in your respective classes, because I can't correct it today because the Monday class had one class short because of last week, the Shorter Baptist holiday. So I thought to myself, it will not be fair to them to do it today, because then they will not get any homework, and we have to give you all homework. So I will not do the correction of the homework today, but rather I will do it in your respective classes, right? Be it the Monday, the Wednesday, the Saturday class. Okay, so vectors, right? We're starting off with vector and scalar quantities. So to understand vectors, we must first be able to distinguish between two measurable quantities, a scalar and a vector. So a scalar quantity is a measurable quantity that possesses only magnitude. That's an important thing there, right? It possesses only magnitude. Good morning, Shushmita. The scalar has no direction. Some examples of these are distance, speed, area, volume, length, time, age, and mass. They have no direction, right? They only have magnitude. So a vector, on the other hand, a vector quantity is a measurable quantity that possesses both magnitude as well as direction. So again, the difference between a scalar and a vector is that a scalar has only magnitude, but it has no direction. However, a vector has both magnitude and direction. So some examples of vectors are displacement, velocity, acceleration, weight, etc. Weight has both direction and it has magnitude as well. So we use line segments to represent vectors, and the direction of the arrow shows the direction of the vector, right? The difference between a scalar and a vector can be seen in the diagram below. So this is a line segment, QP, and this is supposed to be OP, right? And this is a vector, OP. So the vector OP, you're all seeing how I have an arrow on top of the OP, right? That indicates that there is direction here. It's distinct from the scalar OP. This is supposed to be an O, right? Again, it's supposed to be an O, whose line segment is not arrowed. So as you all can see, this one have an arrow here. This indicates that there is direction. So when we are writing OP, we write OP with an arrow on top. This arrow means vector OP, and that's how you will read it, vector OP. So the direction of the arrow is not shown in OP here, so that means it doesn't have any direction, it just has magnitude. Any questions so far?
No, sir.
All right. Vector notation now. Now a vector is written or named as a line segment using two endpoints with an arrow at the top. The arrow indicates the direction of the vector. So the vector OP is written as OP with an arrow on the top. Yeah? In this case, the direction is from the point O to the point P. So as you can see, it's from O to P. That's the purpose of the arrow. The point O is the tail of the vector, and the point P is the head of the vector, as it can be clearly seen here. Yeah.
Your screen is corrupted on my phone.
My screen is corrupted on your phone. How come?
I have no idea, but it's shifted sideways. Like going.
You can adjust my screen from your screen, or like in terms of how it shows on your phone.
Take off your rotation. Take off your rotation and put it back on.
No, I was so.
Try, JL, you could try logging out and coming back in and see if that helps. Because I have my screen on my phone as well, and it looks normal to me. So I'm assuming it looks normal to everybody else. Is anybody else having a problem?
No, we don't have none.
Anybody else having that problem?
No, sir.
No.
All right. Yeah, I think it's just the rotation with respect to her phone. That's not. I think she just WhatsApped me. Hold on. Oh my God. Wow. Okay, JL.
Yeah.
Yeah, I think you're gonna have to like log out and log back in and see if that helps.
Okay.
Yeah, so hurry up, right? I don't want to continue the class and you're missing out on pertinent information. Let me just pause this recording. Somebody just remind me to. Thank you. So in this case, the direction is from the point O and the point P. I think I read this already, right? Also, a vector may be symbolized by a letter written in bold print, such as A, or an underlined letter, such as E, but it's supposed to have an underline here, right? To indicate that a quantity is a vector. So we may write vector OP with the arrow on top equal to E. In other words, we can replace OP with E, and you all will see it in past papers and questions that are going to be coming up soon. Okay, so again, you can represent a vector like this, or you can represent it with a bold letter, or a bold letter with a line to the bottom of it. I forgot to put the line here. Okay, so these are just some general knowledge. I'm going to just recap quickly with you all. So a ray is usually used to represent a vector, and this is what a ray looks like. All right, a vector can be named with two letters, as in A, B with an arrow indicating its direction, or it may be named with a single letter such as X or U, etc. Okay, and as you all can see, it's underlined here. Vectors can be added, subtracted, multiplied, and divided. They can also be shared in a ratio and be measured. So if the vector A, B, and as you all can see, it's going from A to B, is positive, then if we go from B to A, it will be considered as negative. Again, I'll repeat that. If it's going in this direction, A to B, then it's positive. However, if it goes in the reverse or the opposite direction, such as B to A, the vector is considered to be negative. Any questions so far? Make sure and remember this piece here of information here is very, very important. Do you have any questions? I want you all to memorize that. If we have A to B, it's positive, but B to A, it's negative. Okay? All right. And we say that AB and BA are opposite to each other. Notice that they run in opposite direction. So if AB and BA were to be added, the resulting sum would be 0. So for example, let's just say that AB turned out to be 1. And that will obviously be positive, right? And BA will be what? Anybody?
-1.
Correct. -1. So if we were to add them to each other, +1 and -1, our result will obviously be 0. They will cancel off each other. Okay? So that goes to say that vectors can be equal, opposite to, parallel, or run into each other. Now this here is also very important. That's why it's highlighted. Vectors are equal if they have the same magnitude or length. However, vectors are parallel if they have the same direction or the same angle. This is also very important. Okay? Any questions so far? Okay. Never had a question?
No, sir.
Okay, all right. Position and free vectors now. So I want you all to notice that the vectors O, A, O is from the origin here, right? So this is O. Everybody seeing it here? O to A, O to B, right? So notice that the vectors OA with the arrow on top and OB start from the point O, which is given as the coordinate 0, 0, yeah, or the origin. Now these two vectors are called position vectors. Position vectors usually has the first letter being O, And position vectors, they start from the origin. So again, position vectors start from the origin and they begin with O. So let's say you see OB, OA, OC, OR, OQ, etc. All of those will be considered position vectors and they will start from the origin. However, if you see a vector such as PQ, as in this line here, right, and you're seeing PQ, it is not attached to anything. So it's not attached to the origin or anything of the sort. So this is called a free vector. So again, a position vector starts from the origin. A free vector, it lies somewhere within the diagram here, but it's not attached to anything. It's not connected to the origin or anything of the sort. So this is called a free vector. Any questions so far? No?
No, sir.
All right. Let's see here what it says here. A vector can be written in what we call its component form, which is a column matrix. Hence the reason I taught matrices before I taught vectors. So when I talk about terms like column matrix, you're also supposed to know what I'm talking about, and there should be no confusion. I taught column vectors last week Sunday, and I believe it's
last Sunday.
yeah, and I believe it's already up on the YouTube channel, right? So if you all didn't look at that, then I'm sorry that, but you wouldn't be able to follow in today's class because vectors, it has a lot of matrix components in it as well. So you need to understand those things, right? So the component form of a vector is given as x, y. So just like when we did coordinate geometry, remember we had the coordinate. Remember that? So like we had x, comma, y, and sometimes you get something like 0, 4, etc. You all remember that from coordinate geometry?
Yes, sir.
Right.
Yes, sir.
So right. So now with matrix, it's in a column vector form. A column vector only has one column, right? So it will be in the form x, y, and if we were given a set of coordinates, it would be 0, 4. Let's say we were using this coordinates here. Yeah? Yes, people?
Yes, sir.
All right. So let me just quickly erase all of that. Right. So for position vectors, the component form x, y is simply the coordinates of its endpoint written as column matrix. So the component form of OA, let's look at OA here, right? It's just now the component form of, right, 5, 6, right? So the component form of OA, we're looking at the endpoint, right? Because I think it says here is the coordinates of its end point. You're seeing that here, this end point. So the end point is wherever the arrow ends. And of course, the x coordinate goes first. This is the x-axis here. This is x, this is y. So the coordinate for x will be 5, and the coordinate for y will be 6. So the coordinates of OA, the endpoint of OA will be 5, 6. Let's look at B. What is the coordinates for B? I would like for somebody to tell me, call somebody's name. Tell me please. Let me see. Let me choose somebody at random. Angelica.
Yes, sir.
You can tell me the coordinates for the vector B.
Is it 5 and 2?
Correct.
Okay.
Yes, 5 and 2, that's correct. So as you all can see, she is correct. The x coordinate is 5 and the y coordinate is 2. So the position vector will be 5, 2. Now the component form of the free vector PQ may be found by subtracting the starting point from the end point. And again, this is English where English will take place, right? The starting point is subtracted from the endpoint. So you will put the endpoint and then you will take away the starting point from it, right? So let's see the starting point here. The starting point will be 1, 7. That's where P starts. It ends at 6, 4. So again, the starting point 1, 7, and the end point 6, 4. So we will put 6, 4, take away 1, 7 in its component form. This is column vector form. And of course, 6 take away 1 is 5, 4 take away 7 is -3. So the vector PQ is 5, -3. It's no rocket science with vectors here, right? Anybody have any questions? Anybody want me to redo anything quickly for them?
Yes, sir.
Okay, so everybody following, right? That's great. Vectors real nice, you know, except when it comes to the laws, the triangular law, the parallelogram law. The parallelogram law, parallel law. I can't even remember. But I know the law. Anyway, so let's look at magnitude and direction. This is also very important. The magnitude of a vector as well as the direction of a vector. So when you get the product, you're going to have to memorize these, right? So using the component form of a vector AB, which is in the form x, y, the magnitude of AB is given as the square root of x squared plus y squared. Units, of course, because again, magnitude deals with like units and stuff. So like centimeters and all of those things. So that's why we have to put units. And the direction or angle is given as tan inverse of y over x. Okay, and I'll show you how to get tan inverse in your computer, in your calculator. Right? So look carefully, it's tan to the power of -1, right? And y over x. You're saying that? Right? And of course, this here is AB is the square root of x to the power of 2 plus y to the power of 2. Yeah. So let's look at some examples here. So given that vector OA is 5, 6, and vector OB is 5, 2, and vector PQ is 5, -3, determine the magnitude or length of OA. So again, the magnitude or length is given as the square root of x squared plus y squared. So if this is OA, this is x squared here, this is y squared here. So 5 squared plus 6 squared. 5 squared is 25, 25 plus 6 squared is 36, so 25 plus 36 is 61. So the vector OA is the square root of 61 units. Now you can leave it as this, because obviously if you were to find the square root of 61, you will get a decimal, so you get like 7.8102496676 and a long answer. You can leave your answer in square root form. This is referred to as, this is called in AdMath, it's called a surd, right? You can leave it in surd form. All right. If you want, you can put the long thing and you can approximate it to 2 decimal places and stuff like that, or you can just leave it as this. And of course, you have to put the word units at the end. Yeah. Any questions so far?
No, sir.
Right. Now, when you are doing vectors with respect to magnitude, it's important that you put the lines, these 2 lines here. You're seeing these 2 lines here at the end of it. That means the absolute value of OA. That simply means it's neither positive nor negative. It's just an absolute value. Okay. Now let's look at the direction of OA. Let's say we were asked to find the angle or the direction of OA. They can use the words interchangeably, right? They can use direction or they can use angle. Of course, we know it's y over x, and of course it's OA. So y is 6 and x is 5. So on your calculator, let me just quickly show you all. Are you all seeing it here?
Yes, sir.
Right.
Yes,
So
sir.
to get tan inverse, you just look for where you see tan on your calculator. Let's see if I could get the, yeah, you all seeing tan there? And if you all look, by the way, let's suppose I have a calculator on standby, right? If you all look carefully, on the top of the tan, you will see tan to the power of -1. That's I got my finger too far to put there. You see tan inverse there? So to access, right, to access that, you press second function, tan, and you're seeing it come up here, tan inverse, and you just simply put an open bracket. It's, I think, 6/5, so 6, it's a fraction form, 6/5. You close the bracket, you press equal, and you will see 50.194 and that long thing. Again, I'll read it one more time. Second function, tan, so tan inverse comes up. So you open a bracket now, 6, press your fraction knob, 6/5, you close the bracket, and you press equal sign. So you get 50 point something. Yeah. Okay. Right. So as you all can see, it was 50.19. So we approximated it to 2 decimal places. Sorry, to 1 decimal place. So 50.2. And of course, it's direction / angle. So it's 50.2 degrees. Don't just put 50.2. Whenever you're dealing with tan and stuff, is in degrees you're dealing with. So any questions so far? Anybody, anybody confused? Anybody head hurting them? Okay. Let's continue then. Now addition and subtraction. Just 1 minute. Okay, Anissa, I'm now seeing your message. If I read my message, I will see what you said. What are you saying? You are hearing me talking, but you're not understanding anything. Okay, well, you need to turn on your audio, right? Because I did mention to you all that when it's like this, when it's on the screen mode, I am not seeing the messages from you all. If you all turn on your mics and you ask a question, then of course I will be able to hear you. Okay, so if you message and I'm not reading it, that is not my fault, okay? I did mention that to you all a couple classes are back. And I always tell you all to put on your mic and whatnot, because I don't always read the messages. It doesn't always pop up on my screen. I will see it blinking, but like when I turn from my phone to my laptop and I'm switching constantly, it's very difficult for me to catch up on the messages. Unless, of course, I give you all a question to do. And if I give you all a question to do, then I will pop up the chat on my screen. So yeah. You sure? You want me to explain something for you? Just let me know now. Okay, no problem. So addition and subtraction and multiplication. So let's define two vectors. Let's call it U and V. Remember, we can call vectors by their letters, or we can put OA, OB, OR, etc. So in this case, we are defining two vectors, U and V, such that U is equal to vector OA plus vector OB, right? And V is equal to vector OA take away vector OB. Then we could add and subtract the two vectors in their component form. So let's see here. Now remember, we were given vector OA and OB here, right? So I want you to just quickly take a jot down of what these vectors are, because we're going to use it, right? So I'm giving you a couple seconds to just take down what OA is, what OB is, and what PQ is. Okay, I'll take it out. Right. So OA would be 5, 6, and OB will be 5, 2. So 5 plus 5 will be 10, and 6 plus 2 is 8. So the value for U will be 10 and 8. Similarly, OA is 5, 6, and OB is 5, 2. So if you want to subtract them, 5 take away 5 will give us 0, and 6 take away 2 will give us 4. So the value for V is 0, 4, and the value for U is 10, 8. Anybody have a question?
Go over that one more time.
So you can repeat that?
Sure, no problem. So we have two vectors. We have U is equal to OA plus OB. Of course, you'll have seen the arrows on top, so it's vector OA plus vector OB. And of course, V is equal to vector OA, take away vector OB. So we can add and subtract the two vectors in their component form. Component form means column vector form, right? So of course, OA is 5, 6, as what I would have made you all right on that just now. And OB is 5, 2. So 5 plus 5, we are adding across. With vectors, we add and subtract across. Right? So 5 plus 5 will give us 10, and 6 plus 2 will give us 8. So that means the value of the vector U will be 10. The coordinates of vector U will be 10 and 8. Similarly, we have OA take away OB. So we put the value of of OA, which is 5, 6, and then OB, which is 5, 2, which I would have gotten from this thing here, what I asked you all to write down. Yeah. So 5 take away 5 will give us 0, and 6 take away 2 will give us 4. You all understand now?
Yes,
Yes,
sir.
sir.
Okay, great.
Yes, sir.
All right, nice. So we could also choose to change the length of a vector by using a multiplier called a scalar. Now remember when we were doing matrices, right? We had, just now I'm trying to get the, right, when we were doing matrices, we were given A as, let's just say, 2, 4, 6, 8, right? And then if we were asked to find 2A, multiplied everything inside of here by 2, remember that? And we would have gotten 2 by 2, which is 4, 4 by 2 is 8, 6 by 2 is 12, 8 2s are 16. So 2A would have been 4, 8, 12, and 16. You all remember that how we did matrices?
Yes, sir.
Yes,
Right.
sir.
So it's basically the same concept. A scalar is a number that you multiply a particular set of values by, and you get a magnified quantity. Yeah? Or depending on how the scalar is written, you might get a smaller quantity as well. So it actually changes the magnitude of the vector, right? Or the length. So for example, if W is equal to K multiplied by OA, where K belongs to the set of real numbers. Real numbers mean it can be any number, okay? So this is just, I'll repeat it again. They are defining the vector here. They are telling you W is equal to K multiplied by OA. So whatever OA is, you're multiplying it by K. And they give us an example here and telling us that W is equal to 3. Sorry, that K is equal to 3. So the scalar quantity is really 3. And since we know the value of OA, as you all can see here, is 5, 6, we can put 3 on the outside and multiply by 5, 6. So of course, 3 by 5 will give us 15, and 3 by 6 will give us 18. Any questions so far? Anybody want me to redo this part here?
Yes, please.
Okay, no problem. So we are given K as a scalar quantity, right? And we know that, just now, let me use my pencil. Right, so from here, we can see that the value of OA is 5, 6. So in this case, they give us the scalar quantity K to be 3. So it's 3 by the vector OA, which is 5, 6. And remember when we were doing matrices, it's just 3 by 5. will give us 15. And of course, 3 by 6, which will give us 18. Right? So this will be 518, which is what I have here. That's basically it. Any questions? Anybody have any concerns? So
So,
basically, yeah.
K to the element of R, what that means?
If what?
K to the element of R, what that means?
That means it just means that K, this, I didn't teach you all set theories yet. I taught it in the Saturday class. This symbol that looks like an E, it means that K belongs to the set of real numbers. R means real numbers. I taught you a lot in the first class. So it means that K is any real number. So it could be 3, it could be 4, it could be 5, it could be 0, it could be 10, it could be a million, it could be whatever. It could be -2, -3, etc. Yeah?
Oh, okay.
Yeah, and the reason why I didn't teach set theory to you all as yet, because that is not tested in the paper 2. It's tested in the paper 1. However, now that the exam is only paper 1, I will have no choice but to teach you all set theory in great detail, because I don't know how the question is going to come at the end of the day. Right? So any Sunday class or any other random class, I will do some set theory with you all. It's a big handout, and it's very important, and it used to come every year in the paper 2, and it was an easy question to get full marks in, because the questions, they never really change so much. And in the multiple choice is very easy as well. So yeah, let's look at this case here. So we are given the same scenario here, but it tells us that K is now a half. Okay, so now we are multiplying a half by OA, which in this case is 5 and 6. So a half of 5 is just 5 over 2. If you want to simplify it further, and you want to put the value of that, which will give us 2.5. If you want to put that, you can go ahead and put that 2. And of course, 6 over 2 will give us 3. So this will be the coordinate here, which is what I have here. Any confusion so far?
No, sir.
Anybody confused? Say no or forever hold your peace. No? Okay. Anybody saying anything? Okay. I'm assuming that you all understand it. Okay. So we could further define other vectors, such a vector that z, this is a z here, right, is equal to a half of u minus 3v. So a half of u, and remember, I gave you all u as this here, 10, 8, and v is, of course, 0, 4. And if we are asked to give the values of z, z is a half of u minus 3v. I want you all to try this question for me now. I'm giving you all 5 minutes. I'll be back in 5 minutes, right? And you all can share the answer in the chat. Okay, so I'm seeing some correct answers. Desha, your answer slightly off. Check your signs. Okay, let's see. Of course, it's a half of u, right? One moment. Right. So the half of u, and the value of u is 10 and 8. And of course, the value of v is 0, 4, right? So the question tells us that z is such that it is a half of u minus 3v. So of course, a half of u, it's a half of 10, 8 minus 3v, which is 0, 4. So a half of 10 is 5, and of course 8 minus 3 by 0 is 0, and 3 by 4 is 12, right? So 5 minus 0 is, of course, 5, and 8 minus, oh sorry, a half of 8 is 4, right? And 4 take away 12 is negative 8. So z is 5, negative 8. So how many of you got that? I see a few of you got that.
Me, sir.
Okay, good. Nice. So can I erase it now? Jaden, are you understanding? You following? Jaden, Edmund?
So I don't think you hear.
Oh, I see them online.
Yes, sir, kinda.
You sure, right? You want me to explain anything?
Yeah.
What do you want me to explain?
We can start from the beginning.
Again, that's why.
The beginning of the handout or the beginning of this question?
Another discussion.
Oh, I thought you wanted to start from the beginning of the handout. I was now going to say, what? Right. So we were asked to find z, and they tell us that z is a half of u minus 3v. So in other words, we are magnifying u, which is this, by a half. So we're multiplying everything in here by a half, and then we're taking it away by 3 times everything in v. So this is the magnification of v. So z is a half of the value of u, which is 10 and 8, minus 3, and the value of v is 0, 4. So of course, let's just do it. I'll break it down further. A half multiplied by 10 is the same as 10 over 1. So 2 into 2, 1, 2 to the 10, 5, right? So on the top here, you'll get 5. And of course, a half multiplied by 8 over 1, 2 into 2, 1, 2 into 8, 4. So we get 4 minus 3 by 0 is 0, and 3 by 4 is 12, right? So I could erase this little work in here now. But that was just to show you how I get the 5 and the 4, right? So 5 take away 0 is 0. And of course, 4 take away 12, you can use the calculator, right? So 4 take away 12, the answer is negative 8. So negative 8, and that's the answer, that's it. You understand?
Yes, sir.
That's supposed to be 5, eh?
Oh,
Yes, sir, that's
I meant
okay.
to write 5. I was just checking to make sure you all were paying attention. You know, I like to try these things in between to make sure that people are paying attention. I'm very glad that you all are paying attention. Very good. So can I take off the screen now? Great. Share screen. Right. So yes, the answer is correct. It's 5 and 8. So we could also calculate the magnitude and the direction of these vectors if we wanted to do so as well. Sorry, if we wanted to do as well as compare vectors to each other to see if they are parallel to each other, or to see how much longer one is than the other, or if one is a multiple of the other. Now these two things are called parallel vectors and collinear vectors. We're going to learn about those two things just, all right? So these two comparisons are often referred to as geometric relations between vectors, right? So two important rules to consider. The first one is the triangular law. Now I have, these I take from two different handouts, right? So we're gonna learn the triangular law from this handout, and if you all didn't pick it up in this handout, then you will certainly pick it up from the other handout, okay? Or vice versa. So let's just read this handout first. So two important rules to consider is the triangular law. The first law is the triangular law. We call the arrowhead on a vector its head / the nose. Somebody, mic is on. Right. So if two vectors are arranged head to tail, that is, if one runs directly into each other, as you can see here, head to tail, this is the tail, right? Let's just get the red thing. Right. This is the head here, this is the tail of the other one. So if they are arranged head to tail, that is if one runs directly into the other, as it can be seen here, then the sum of these vectors is called a resultant, and that resultant is found by adding the two vectors. So if you want to find the result, which is from here to here, we just add A and B. Any questions so far? No? Okay, let's look at this diagram here. A, look here, A is here and B is here. It's arranged head to tail, and they're running in basically into each other. Yeah, so the result will be A plus B. Y'all seeing it? As you all can see in this other diagram here, A is going here in this direction and B is going in this direction. So B is going in the opposite direction. So remember I told you when it's going in the opposite direction, it's negative. So A is positive, B is negative. So in that case, to find this here, it will be A minus B. Any questions so far? Anybody want me to repeat it? Say no.
Yes, sir.
Sir, me, please.
Sure, no problem.
So you can check your WhatsApp, please.
Okay, no problem. One moment. Okay, I have no idea what's going on. Is it still happening, Nisha?
Yeah.
Oh, anybody else's screen is blinking?
No.
Oh,
Yeah.
I think it's probably
No.
your laptop.
So my screen doing the same thing I showed you, but it coming back normal sometimes.
Oh,
There's a rotation.
It's only happening with the Zoom. The
It's not
laptop normal,
rotation.
only with the Zoom.
It's not
Okay.
rotation.
Well, they shall try logging out and logging back in then. I'll wait for you. I'll give you 2 minutes.
I'll do that already, sir.
And it didn't work?
Same.
No.
Oh, man on that. But what about the audio? The audio working good?
Yeah, working good.
Okay, well let me hear what. Let me email you the handout then. So if it's at a blink again, you go in fact I will not email it, I will send it on the group. I'll send it for you on the chat. Everybody else will get it after. But because you have a little technical difficulty. WhatsApp web.
So I think they should come log out and then come back in.
Me?
Back.
Who's on me? If I log out, I everybody else will get kick out.
No, not you, sir. Damn it, this year.
All right, Disha, I'm gonna send it for you, all right? Try to see if you can follow along from it then.
Okay.
Don't know what you get. You get?
Yeah.
All right. Okay, so let me see here now where we reach. So we're on page 6, Disha.
Okay.
So, right. Is it still jumping or no?
Still doing it. On, coming on and coming off.
May I know how to help you then, huh? Well, if you miss anything, you will just have to get from the recording from the YouTube channel, right?
Yeah, no problem.
Yeah. So you too, right, JL? So again, this is arranged from head to tail. So A going to B, and they're going more or less in the same direction. It's not that much difference in terms of direction. So to find the distance here to here, it will be A plus B, right? Similarly, if you all can see here, we have A, and then we have B here. So to find this long line here, it will be A plus B. Similarly, not similarly, but conversely, we have A going here, it's touching the B here, and if you all notice, B is going in a different direction. So it's minus. So in this case, to find the result here, it will be A minus B. So if, however, the vectors are not arranged head to tail as shown in this diagram here, so you all can see they are running into each other, right? So A is coming here, and B is running into each other here. B is running into A. They're not going in the same direction. And we have to find AC. We will have to reverse the direction of one of the arrows, making the value of that vector a negative value. So if you want to find AC, it will be A to B plus negative B to C. Anybody do not understand what I'm saying here? You can only use the triangular law if they are arranged head to tail. In this case here, they are not arranged head to tail. They are running into each other. As you all can see with the arrows here, the direction of the arrows, they are running into each other. So in order for this to be corrected, we have to say A, B plus, and we change the direction of B, C, and the only way to change the direction is to change the sign. So this becomes negative BC. So of course, a positive by a negative will give us a negative. It will be AB minus BC. Any questions so far?
Sir, can you repeat that again, please?
Sure, no problem. Let me do it on the whiteboard. So we have a diagram here. We have A, B, sorry. We have A, C. As you can see, A, B, and B, C are running into each other. They are going in this direction. And for us to use the triangular law, they have to be going in the same direction. So as you can see, it's a free-flowing diagram here. And it's arranged head to tail. This is not the case here, so we cannot use the triangular law in its entirety here. So for us to use the triangular law to find AC, which is here, right? If we want to find AC, AC will be AB, of course, vector AC is equal to vector AB plus, and we cannot use BC as it is here because it's running into A. So we have to reverse the direction here, and the only way to reverse the direction is to change the sign. So BC. Okay, and of course, a plus by a minus gives us a minus. So AB minus BC will give us the value of AC. You follow?
Yeah.
Any questions there, anybody? No? All right.
What's the
Okay. Now we're going to look at the parallelogram law. I'll try to explain the triangular law again differently using our next diagram in the next over here, right? This explanation here. But if you of course understand it from here, then you don't need to understand it in the other one. So the parallelogram law. Now this law is kind of confusing, right? So I suggest that you will pay attention. It takes me a while to grasp it, and whenever I finish teaching it, I automatically forget it. I don't know why. So if two vectors are arranged tail to tail, so as you can see, tail here and tail here, this is the tail to tail. The rule for adding them comes from the properties of a parallelogram, where opposite sides are parallel and equal. So opposite sides, this side here is equal to this side here is equal to this side on top here, etc. Right? So as you can see, B, A, they are equal to each other. You all seeing it? B and B are parallel and they are equal. A and A are parallel and they are equal. Okay? So we form a parallelogram and we add, and add proceed as the triangular law. Okay? So let's look at it in a different sense here. I'll redo the triangular law and then I'll redo the parallelogram law, which will explain both of them further for those who did not quite grasp it. Oh wait, I forgot to explain the parallel law, sorry. So it's arranged tail to tail, right? And we want to find the distance from here to here. So all we have to do is add A and B and then we will get the answer. It's as simple as that. So let's just see. The triangular law of vector addition and pattern follows a pattern when we observe any statement of its application. This pattern allows us to predict the resultant without even drawing the triangle. So as you can see here, we have C to B and then B to A. So if we want to find CA, it will just be CB plus BC, BA. And of course, A to C, and then C to B. This will give us the value for A to B. It's basically the same thing as the one before. It's just done in a reverse direction, okay? So for a given triangle, ABC, we have AB, BC. These two letters must be the same because both vectors share this vertex. So as you can see, they have something in between in the middle here, B and B. So if you have B and B here, the result will be whatever remains, which is A and C. That's basically a hint to remember the triangular law. So you're seeing here, B and B here, and what is on the end is C and A. So the answer is C and A. Right? Let's look at the ones we had before. Oh, this is different, sorry. In this, we were actually given the name of the vectors. So the result is always the connection between the starting point and the end point. So let's look at these here. I would like to call on 3 people to tell me the answers for this, right? First person will be, one moment, let me see. Cheyenne, you will do the first one. The second one will be done by Hania. And then I'd like to call on JL to do the third one. So the first one, take it away, Cheyenne. PQ plus QR. What is the answer? Cheyenne?
PR.
Correct. That's correct. Because remember, I told you all, if we have PQ plus QR, and of course, these two here are the same, then the answer will be this and this. So it will be PR. Of course, vector PR. Yeah? Any confusion there? Okay. Second person. Ania.
Yes, sir.
Hi, can you tell me the answer for the second one?
RQ.
Yes. So RP plus PQ. Of course, vector. because we have P and P here, the result will be RQ. And of course, this is using the triangular law too, right? All of this is the triangular law. Make sure you all understand these things, because when we come to the participles, you'll have to understand it. Okay, JL, your turn. QR plus RP. JL. JL. Okay, can I call somebody else then? JL is not answering. Musa? Musa? Everybody hiding now. I seen all online, you know.
So I could answer it.
Well, boy.
Yeah, go ahead.
QP.
Correct, because as you all can see, you have RR, so the result will be QP. Vector QP, of course. Right? So it ended quite easy, right?
Yes, sir.
Right? So of course the answers are here. The parallelogram law now. Let me explain it in a different sense now. So if two vectors are represented in magnitude and direction by adjacent sides, that means opposite sides, of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram. So the diagonal here, right? So when adding two vectors that start from the same point, so they start from the same point, we use the parallelogram shifting one of the vectors to the endpoint of the other. In doing so, we form a triangle whose third side is the resultant of the two vectors. This is illustrated in the diagram below. Right? So let's explain the parallel. Let me explain the parallelogram law. So we have A going to B, and then we have A going to D. Let me draw it. So we have this and we have that. So we have A going to B, right? And then we have A going to D. You all seeing that? You all seeing that?
Yes, sir.
All right. So by the parallelogram, A plus B, sorry, AB plus AD will give us AC. So C is here. AC. Okay, that's going here. But BC is equal to AD because of the law, sorry, because of the opposite sides of a parallelogram. So we can draw this here. Okay? Y'all following? Y'all following?
Yes, sir.
All right. And of course, we know that AB, that's this side here, is equal to, just now, hold on. We may replace, oh yeah, sorry. I jumped in the gun. So we can replace AD, which is this here, this piece here, right, by BC to get AB, which is this here, plus BC. And this will give us AC. It's kind of confusing, right? So you'll just need to understand it. So again, we could, because of the parallel, the sides of the parallelogram, the opposite sides are equal and parallel. We can say that AD, we can replace AD, sorry, with BC to get AB plus BC. Are you following? And of course, you just draw this line here and you get a parallelogram. It's kind of confusing, but you just need to go home. Well, not go home, but You just need to, when you're at home and you're studying, you just need to massage it into your head and practice with it, okay? And then, of course, when we come to some past,
Excuse me, sir.
sure, yeah,
Can you explain it over, please?
sure, no problem. So you are given two vectors, A, D, and A, B, right? And of course, the parallelogram law says that AB plus AD will give us AC. That's this piece here. So this will be C here, basically. All right? You following so far, Hania?
Yes, sir.
Right. And because we know that BC is equal to AD, which is this side here, right? We could replace this AD side here by BC, which is here, to get AC. In other words, all you have to do is just draw a line here, and that is it. Any questions? Anybody? The aim of the parallelogram law is just to find this line here now. That is all. And once you find that there, you just draw the lines, the other lines, and you're done, more or less. It is confusing a little bit, but don't worry, when we come to do some past papers, it will make sense to you all, okay? So let's look at this here. I want you all to do this example for me, this one for me here. Do the 3 questions, and I'll call on 3 random people to answer it for me, okay? I want you all to find OA, OB, and AB. Oh, let me take your roll. You can share your answers, eh? Nirvana, how come David not online?
I don't know, sir.
He in the class or no?
No, unfortunately.
Oh, okay. Anybody got something for OA?
Yeah.
Yeah.
3 and 0.
3 and 0? No.
I get
Minus
0 and minus 4. Wait, what? Minus 1?
minus 4 and 3.
No.
Minus
No,
1.
minus 2 and 3.
Nope.
Where's this at 4?
Yeah, Regan is the only person get correct. Remember, right?
The people say that.
No, they didn't say negative 1 and 3. Yes,
I
correct.
say
John.
minus 1 and 3.
Oh, sorry, I didn't hear you. Remember, it's the end point, right, of the vector. And of course, you read the x value first, so it's negative 1. And of course, the y value after, which is 3. Yeah? So the value for OA is negative 1 and 3. You all good? Any questions? What y'all got for OB?
5 and 2.
Correct, because of course the x value is 5, so it's 5, and the y value is of course 2, so 5 and 2. Anybody figure out AB?
Yeah.
Where you go?
5 and 2.
Nope,
4 and 2.
nope,
6 and 1.
Minus 6, 5.
nope,
No, yeah, this side was
Minus 1 and 6.
nope. Oh yeah. Nirvana, your answer is correct. Say why not? Nirvana, you can say back your answer?
Minus 1 and 6.
Correct. If you all notice, the direction of A is going this way, right? And the direction of B is going that way. And we want to find out what is AB. Oh God, what do? Right, we want to find out what is AB here. That's using the triangular law. A plus B, okay? But since they are both going in different directions, we need to get them going in the same direction. So we need to reverse the direction of A. Not so?
Yes, sir.
Right. So for A, let me type it out. AB, of course, just picture the arrow on the top, right? Because I don't know how to do that in this here. Is equal, we want to go from A now to O, because remember, before it was OA. We would realize OA, but we don't want OA plus OB. You remember, these values here have to be the same, right? Remember, the A and the O are supposed to be the same. So we need to reverse the direction now. So it's AO plus OB. And as you all can see, now the values are the same. Right? You have the O here and the O here being the same. Any confusion so far? Anybody?
No, sir.
All right. So we're still finding AB. So now that we're going AO, remember we are running reverse direction, it changes sign. So that's now negative, of course, minus 1. Okay, now I have to, actually, I think I have to write it. So yeah, let me write it then. Right, So AO is negative, open brackets. The value of A is what? -1, well, let's just find it, 3, plus OB, which is
5 and 2.
5 and 2, correct? And this will give us, of course, negative. Wait, hold up. Right. This negative and this negative will cancel off with each other. Yeah? So we get positive,
Yeah.
1 plus 5, which is 6. And of course, the negative by the 3 will give us -3 plus 2, which will give us negative,
5, -5.
no, -1.
Ah, I get it wrong.
You can use a calculator there.
I get it wrong. Ha.
Yes, people? So the value
Yes, sir.
is 6, -1. Any questions so far?
No, sir.
So Regan, the answer was technically correct, but because of your science, it was wrong. Johnson, you too.
So wasn't AB -1 and 6?
AB?
Yeah.
No.
Oh, is
Wait, what? AB is 6, -1. Because this negative, when I multiply by this -1, it becomes +1, and +1 plus 5 will give us the 6.
okay.
And then the negative multiplied by +3 will give us -3, and -3 plus this 2 here will give us -1. Okay?
Yeah.
So let me see the answer here properly. Yeah, negative. Yeah, correct. So let me just explain what I did here. So to get from AB, we have to go from A to O, and then from O to B. So the vector OA, moving from O to A, we have to change the direction to ensure that they are nose and tail. So we reverse OA and we use it as what I had here before, right? So negative OA. Follow? Because the aim is to get these two values here the same. Okay. Y'all just excuse me for 1 second. Okay, who wants to share? Where you get?
First one, I get 89.
No. And Sanjay, I think you have an echo. I think both your audios are on both your devices, so it's causing an echo. So it's difficult to hear you.
18 and 8.
Nope. Anybody
Is
else?
it 9 over 6?
Is it 3 and negative 2?
For the first part, Stefan, no. The second part, yeah, the value is correct, but the signs are wrong. But Angelica, yes, your answers are correct. Your answers are correct. So let's see it. Let's try to work it out here now. Okay. So we are given OA as 6, 2. And of course, we are also given OB as 3, 4. And OC as 12, negative 2, right? Of course, vector, vector, vector. And we are asked to find BA. So we know we have to start with B and end with A, right? However, we're not given any of that here. We are given OA and OB. So we have to reverse the directions now. Agreed? We have to go from B to O, right? And then O to A. The aim is to make these the same. And with the triangular law, I hope you all remembered, if we have BA, that means we know B and A going in the end. Tail, head. And of course, this is the body or whatever, right? And since we change in the direction, if this is 6, 2, it now becomes negative, right? We change in the direction, so we change the sign. Plus, of course, negative OA. Oh gosh, sorry. This will be 3, 4. And this will be 6, 2. So this will now be negative 3, negative 4, plus negative 6, negative 2. Right? And of course, you can use a calculator and you will get the answer to be what? Oh wait, no. We don't have to pass sign here because, sorry, my bad. We don't have to put a negative sign here because OA, we didn't change the direction of OA. OA was already given. Sorry about that. So 6, 2. So sorry again. So negative 3, negative 4, plus 6, 2. Negative 3 plus 6, when the signs are different, you find the difference, which is 3, and you keep the sign of the greater number, which is positive. Again, the signs are different here. When the signs are different, you find the difference, which is 2, and keep the sign of the greater number. So 3, negative 2. And this is, of course, BA. Any questions so far? Anybody want me to do back? Anybody
No,
want
sir.
Understand.
Okay, great. The other part now, they are asking us to find BC. Taking this off. And these are possible multiple choice questions. When it's coming short and easy like this, it could possibly come in a multiple choice. So BC, vector BC, of course. So again, we're starting with B and we're ending with C. So of course, you have to pass O there and an O there because of course it's only O's they give us here. And the aim is to get these two letters to be the same. So since we weren't given B to O, we were given OB, that means we are changing the direction. So it's negative 3, 4, plus we were given OC, so this is 12, negative 2. So this will change this entire thing here to negative 3, negative 4, plus 12, negative 2. And of course, if you're confused, you can use a calculator. Negative 3 plus 12 is how much? Anybody?
9.
correct? 9, positive 9 because it keeps the sign the greater number. When the signs are the same, you add. So it's
negative 6.
6 and you keep the sign the greater number. So yes, correct. 9, negative 6. And that's the answer. Any confusions?
No, sir.
No? Anybody needs anything to be redone?
No, sir.
No? Okay, great. So let's move on now to parallel and collinear vectors. I will give you a little break today, right? I'll give like a 10-minute break after.
Thank you, sir.
All I want it now, or all I want it when we finish with this 2 pages? The thunder is sounding like a goat in labor.
Well,
You all want to break now or after? So fast? After, okay. Yeah, okay. Yeah, all right, no problem. So let's just get the notes out of the way, and then we will start with the past papers and stuff. Okay. What does it mean to be parallel? And also we're gonna do proving parallel. So the earliest definition we learn of parallel lines is that they travel together in the same direction and they never meet, of course. Yeah, Jaden, we see it right on the screen, huh? This definition is useful. Another definition says that parallel lines have the same gradient. A principle you learn in coordinate geometry. Again, we did coordinate geometry, so all of those things would be connected, right? Combining these two definitions, we can formulate a suitable definition of what it means for two vectors to be parallel. When it comes to vectors, if we are to prove two vectors are parallel, it is necessary to show that both vectors have the same direction. This can be done using the principle tan inverse y over x, which is what we did when finding the magnitude of the vector or the angle. That is, we can just find the angle for both vectors and show that they are the same number. However, it is enough to show that one vector is a multiple of another. So for example, if we are given vector AB and the column vector is, of course, common A, common B, to show that AB is parallel to another vector CD, we need to show that if CD is K multiplied by the vector, where K is a real number, we will get the same, we will get something that is a factor or a multiple of something, right? So let's just see here what I mean by that. So if I tell you AB is 3 and 2 and CD is 6 and 2, right? We can see that CD is really twice the value of AB, because 3 by 2 will give us 6 and 1 by 2 will give us 2. You're seeing it? You're seeing it?
Yes, sir.
Again, A is 3, 1, and if we multiply everything by 2 here, we will get 6, 2, which is really CD. So we can say here that CD is twice AB. So in other words, we can say that CD is a multiple of AD. So because they are multiples of each other, we can safely say that they are parallel. Any questions so far?
So say you had to find K.
Yeah, more or less. No, actually no. You guys have to see whether they are multiples of each other. Let's give him a minute, right? Right. But if you don't want to go through all that craziness, use this. Right? So it will be tan inverse. Let's say we're doing this one here, AB, right? Of y over x. Sorry. Yeah. So tan inverse of 1 over 3, and you will get 18.4 something, right? And let's say you want to find out for the CD, it will be the same thing. Tan inverse of course, 2 over 3 because it's y over x, right? And this will also give you 18.4. I think this is an easier one to do. You all will find so? Yes, Andre?
Yes, sir.
Yes, sir.
The exam is a multiple choice, we would not have our calculators.
Right. So that's why I'm showing you all the two methods as well. So all right, yeah, I know remember, I know catch what you're saying. So yeah, that's very true. So I will suggest you all learn the other method. So yeah, you all wouldn't have the calculators. My bad. That's very true. So yeah, we can't use this method then, but I'm still teaching it to you all.
So,
Yeah.
I thought we were gonna do the exams in like a classroom.
I have no idea how you are going to do the exams. They didn't give any details as to how you are going to do the exams as yet.
I think because it have an extended paper one, they should let us use calculator for some stuff.
Yeah, I think so too.
Like, yeah,
So
because
let me just show you
answers.
let me just show you an easier way to do this then, because you all wouldn't have the calculators, right? So let me see here. So this is obviously the larger number. So you divide this by this. So 6 divided by 3 is 2, and 2 divided by 1 is 2. So that means we know that this is twice the size of this, and therefore we know it's a multiple of the other, more or less. Okay.
So what we're doing is treating it like an equivalent fraction. So what you
More or
get,
less, yeah, correct. Who's writing up on the Thank you. So in this case here, let's say we are given AB to be 2x minus y and CD to be 6x minus 3y. Can we see that this is parallel? Is it? And why? Anybody tell me.
we're not seeing the information.
Oh, sorry.
So I think it's parallel because you multiply by 3.
Yes, correct. Because 6 divided by 2 is 3, and negative 3 divided by negative 1 is also 3. So yes, they are parallel to each other. You're seeing it? Any questions so far?
No,
No,
sir.
sir.
Yeah, need to, no problem. You just get away and miss from the online class, right? All right, let's continue. Proving collinear points. The word collinear simply means to be the same straight line, on the same straight line. So to prove that 3 points are collinear, we need to do 2 things. Show that one vector is a multiple of the other, which is what we were doing just now with proving parallel vectors. And then we have to show that they have a common point. That is, the vector names have a common letter, which is what we were doing before, if you all can remember. We were trying to get the letter in the middle to be the same. Do you remember that? That's this here. We were trying to get these letters to be the same. This thing here. Okay, Jenna, no problem. All I hear, right? And I see anybody responding.
Yes, sir, we hear you.
Okay,
Yes.
great.
Sorry.
All right. So given that AB is 2, -1, and BC, of course, vector BC is 8, -4, we can show that BC and, sorry, we can show that BC is a multiple of AB, because if we divide 8 by 2, we'll get 4, and -4 divided by 1, we'll get +4. So therefore, this one of them is a multiple of the other, right? And then we can rearrange it to show that, of course, AB plus BC, and we'll get a number in the middle, right? AB plus BC, and they have a common point, which is B in this case. So the common letter will be B, and of course, one is a multiple of the other, so they can be said to be collinear. Anybody want me to repeat that? I know I eat up my words just now, but anybody want me to repeat that?
Yes.
Yes, sir. Repeat, you're talking a little too fast.
Yeah, I know, I realize. Okay, so we are given BC is
It's
8.
possible to show it with a diagram.
A diagram? Wait, a diagram?
Just asking.
I don't have any diagram to show it, and I don't think I know how to show this on a diagram unless I have to plot, because I have to plot it on a graph page to show it on a diagram. It is possible, yeah, but I'll have to get a graph page running. I don't have that right now.
All
I
right.
could, what I could do is show it on the whiteboard. Do it on the whiteboard.
Thanks.
Yeah, no problem. Okay, so we are given AB as 2, -1, and we are given BC, of course, vector, as 8, -4. I want to show that, number one is a multiple of the other, and the second one, that they have a common point. Excuse the handwriting, right? So here we can see that if we divide 8 by this 2 here, we'll get 4. And if we divide this -1 here by this, this -4 here by this -1, we'll get 4. So we can see that they are definitely multiples of each other. Yeah? And the scalar factor here is 4. This is 4 times this. So it's definitely a multiple of each other. So it fulfills this criteria. And also they have a common point, which is B. Right? So we can say A, B plus B, C. They have a common point B. So it also fulfills this criteria. So because it fulfills these 2 criteria, we can say that the vectors are collinear. Yeah?
Yes, sir.
All right. So I want you to do this example for me. And after this example, I'll give you a last short break and then we do some past papers, okay? You could share your answers when you finish, right? Sorry about that. I was just trying to gather some multiple choice for you all. OR, Emily? No, that's incorrect. Okay, so I'm going to correct. All right. So let's pay attention while we correct, and after I'm finished correcting, I'll give you a 10-minute break and then we come back and we do past papers, right? So let's see the first question. So we have to find OP. Of course, vector OP. No, sorry, we are given OP as 2, 7, and we are asked to find oh shucks, no wait.
Yeah.
Oh, yes, yes, right, correct. We are given this and we have to write it in vector form. So that's all we have to do there for A. Part B now. Yeah, part B, we have to write OR in vector form, and we were not given OR. We were given OP and PR. So of course, if we are given O and R, we have, we're starting with O and we're starting with R. So O, it will be O to P, and of course, P to R. Yeah? And of course, OP will be 2, 7, and PR will be, they give us here as 4 and -3. So we have to add it to get OR. So that means that it's 2 plus 4, which is 6, and 7 take away 3, which is, of course, 4. How many of you got OR to be 6 for?
Me.
Me.
Okay, good. Now we have to, okay, they said that a point S has coordinates 14, -2. We have to find RS. Okay, so RS now. Oh, this is a crappy question, boy. Challenging, but that's good. So we have to find RS. So obviously we know we start with R and we start with S. So that means you have to have something in common, which is O. So we have to use RO, and we just found OR. So obviously if we use an RO, we have to reverse the direction. So it's -6, 4 plus OS. We were given OS. Oh yes, we were given OS in this question as 14, -2. They tell us that in the second part, right? Just make sure I'm doing the correct thing. I guess I am. So -6, -4 plus 14, -2. So RS will be, when the signs are different, you find the difference. So 6 take away 14 is 8. And of course, negative, this will give us -8. So positive, wait, sorry, -6. So 8, -6. Anybody got that?
Me.
Yeah.
Yes, sir.
Okay, great. So I'll leave it up there for like a minute for you all to take it down or take a screenshot. This is the other part. We have to prove that PR and S are collinear. Wow. Okay, that's not bad.
Repeat the question, please.
Show that PR and S are collinear. So I will leave this up here on the board because we'll be using it to determine if they are collinear or not, right? Can I do it now?
Yes, sir.
Okay. So we have to show that P, R, and S are collinear, right? So if, as you all can see, we have PR here, yeah, and then we have RS here. Yes, you cannot pull out P on itself, R by itself, and S by itself because that's craziness, right? So if you can see, we have PR and RS, and they both have something in common, which is R, the letter R. So that's one factor in determining if they are collinear is correct. So they fulfill one criterion, which is having a letter in common, which is the R, right? And let's look at them in their current state, right? So 8 divided by 4 is 2, and negative 6 divided by negative 3 is also 2. So they are also multiples of each other. So again, they have a common letter, which is R, and then they also have a common multiple, which is 2. They are multiples of each other. So because they fulfill these two criterion, we can say that they are collinear. Any questions so far? Anybody want me to say back anything? Say now.
So I think you should repeat back that.
Okay. So we have to say if PR and S are collinear, right? So we have PR here and we have RS here. So we can already see that they have a common letter R in common. And for two vectors to be collinear in this note here, right? We must show that one vector is a multiple of the other, and we must also show that they have a common letter, right? So they have a common letter, which is R already, we can see, so that's one criteria they fulfill. And let's look at the values here. We have 8, 6, and 4, 3. Of course, negative 6, negative 3. If we divide 8 by 4, we will get 2. If we divide negative 6 by negative 3, we'll also get 2. So that means that RS is 2 times the value of PR. So that means that RS is a multiple of PR. So we can say that they are collinear because they fulfill those two criterion. The first one is having a common letter, which is R, and the second one, which is having a multiple. They are multiples of each other. You follow?
Yes, sir.
Okay. Anybody else have any questions?
Sir,
Yeah.
can you send me past paper on the group, please?
Yeah. I'm still in the process of working it out. I mean, I'm putting it together. I was supposed to do that this morning. I was supposed to get up early and do it this morning, but I get up like an hour before class start, and I started to make the handout. I was supposed to get up early and do that. So when I give it a 10-minute break, I'll sit down and I will more or less put together that, and I'll send it to you all one time. So don't worry, you'll get it just now. Okay, so that being said, I'm going to give you all a 10-minute break. It's now 11:13. When it's 11:23, we're coming back here, right? You don't have to log out. You could just leave your laptop or your phone or whatever as it is. I'll just pause the recording so somebody could just remind me to restart the recording. Can we correct?
Yes, sir.
Yes, sir.
All right. Let me just pull up the questions here on my computer. Okay. We have the vectors P and Q are, so P is 3, 2, and Q is -1, 4. Find P minus 2Q. So it's obviously 3, 2 minus 2 magnified by this, -1, 4. So 3, 2, this will work out to be, let's do it in steps then. 3, take away, well, negative and negative will be a positive, and 2 by 1 is 2, and 2 and negative 2 by 4 will give us -8. So this will work out to be 5, and of course -6. So A, correct? Shushmita, I think you said it was A, so yes, correct is A. Any questions so far?
No, sir.
All right. Let's look at the other question. But the other question was similar to this, but it was not the same. I hope you all saw that. So it was 3, 2, and of course -1, 4, and is negative P minus 2Q. So it's -3, 2 minus 2 into -1, 4. So this will turn this entire thing to -3, -2, a minus and a minus is a plus, so +2 and -8. So when the signs are different, you find the difference, which is 1, you keep assigning a greater number. Same thing here, this gives us -10. So -1, -10, so the answer is D. Anybody got that? Anybody?
I did, sir.
Okay, great. So item 30 refers to the following parallelogram. W, X, Y, Z. In the parallelogram, R is the midpoint of X, Y. Based on the information, ZR, so Z to Y, negative, let me see. We want to find out Z to R. So I would like somebody to answer this question for me. I would like to call on, let's see, Johnson. Johnson, which one where you got for this one? That's with the parallelogram. And if you could possibly explain it, so if you could turn on your mic. Is it possible? Johnny? Right, okay. But explain how you get E. So turn on your mic now and explain.
So I don't even know if it's correct.
Well, you never know. Give it a try.
What did I get this one?
So you want to find ZR.
CR.
Mm-hmm.
Hold on, sir.
Sure. Anybody else figure it out and they want to share?
So I had B.
B, how you get B?
Because WX and XY is parallel to WZ. So I say it'll be WX. The two of them go in different directions. So I
But
thought it
you know
might
like
have
in
been
different direction, didn't indicate that?
because WX and WZ go in different directions.
WX and W. Right, okay.
Right. So I say it would have been half of WZ plus the WX.
half of WZ plus W. So you're saying A.
Yeah.
And Johnson, you also saying A too, right?
Yeah.
Yeah?
Yeah.
Okay, let me just double check. WX and WC. So ZR, based on the information, ZR is equal to WX plus a half of WZ. Yeah. A. Okay. Let's look at Jan 2018, number 11. Everybody on that? Jan 2018, number 11. Anybody want to share what they got? Sanjay, Emily? Aurelia?
Yes, sir.
OQ to be 26.
OQ 26, correct? So let's see here now.
I keep minusing instead of plusing. I don't know why.
Oh, nah, you gotta check up on that, fix up on that, brush up on that, sorry. PQ is -1, 2, and of course RS is 1, 3. So you want to find out what is OQ. So we go in O to P and then P to Q. Agreed?
Yeah.
Right? So that will be 3, 4 plus -1, 2, and of course OQ. This will give us 3 minus 1 is 2, and 4 plus 2 is 6, so 2, 6, correct? Next part of the question, we are asked to show that OQ is parallel to RS. And remember to show that two vectors are parallel to each other. So let's just OQ is 2, 6, and RS is 1, 3. Remember to show that two vectors are parallel, one has to be a multiple of the other. So this is the larger one, obviously. So 2 divided by 2 will give us 1, and 6 divided by 2 will give us 3. So RS is basically a half of OQ. All right? You follow? Everybody?
Yes, sir.
Right. So we can say RS is a half of OQ and is therefore a multiple. So it is parallel. Yeah? How many of you got that? Okay, nice. So can I erase it? Can I erase it, people?
Yes, sir.
All right, and this is to give a reason for your answer too, right? So the reason would have been RS is half of OQ and is therefore a multiple. And since it's a multiple, they are parallel to each other, something along that line, right? By the way, is this recording?
Yeah.
Okay, great. The other part, they said X, Y, Z is a triangle, and M is the midpoint of X, Z. And they told us that X, Y is equal to A, and of course, Y, Z is equal to B. And we have to find X, Z. Oh, wow, okay, great. So to make life easier, let's construct a triangle based on what they give us, right? So they said here, let me just read back the question. X, Y, Z is a triangle. So X, Y, Z. And they said also that M is the midpoint of X, Z. So here is the middle. So here is M. Oh, my markers are dying. So here's M. So what else I said? And XY is equal to A. So the XY is equal to A. And YZ is equal to B. So we can draw a line here. This is the midpoint, right? Okay, great. Any confusion so far?
No, sir.
All right. So they said here, what we have to find now. They're asking us express the following vectors in terms of A and B. Simplify your answer where possible to find X, Z. X, Z. So anybody want to share what they got? How do you find XZ? Remember the triangular law? If you want to find here, it's just this plus this. So XZ is just A plus B. And that's it. How many of you got that?
No, I didn't get it.
All right. But you understand how I get?
Yes, sir.
All right. So M is the midpoint of XZ, right? Just now, I think somebody messaged. Oh, yeah. M is the midpoint. Oh, we have to find MY. So we're going from M to Y. So let's see how we go in here. Let me just read the question again. MX, M to X, and then X to Y. You all do that? We want to find XC. Sorry, MY. So we know we're starting with M and we're starting with Y. And X had to be in the middle. So M to X, we're going in the opposite direction. Are we? Yeah. So it's negative. These markers are dying. So it's negative a half MX. Wait, I'm doing sharpness just now. It's negative MX plus XY. Nobody confused so far, right?
No, sir.
Okay, see now if all are confused. So MX, remember MX is a half of XZ. MX is a half of XZ. Yeah? Yeah, people? And we found XZ to be AB. So this is really a half of A plus B plus, of course, XY, which is E. Anybody confused?
No, sir.
And you can leave your answer as this. Oh wait, sorry, it's negative a half. So again, let me just repeat it. MY, well, we're starting with M, and we're starting with, sorry, are we ending with Y, right? So X is the common number, the common letter, sorry, and MX, that means we are going this way, so we are going in the reverse direction. So it's negative MX plus XY, and we already found XZ. MX is a half of XZ. So we replace MX with a half of XZ, which is A plus B. So it's negative a half A plus B plus, of course, the A, which is XY. And that is that. How many of you got this question correct?
Me, sir.
Okay. Well, clearly we'll go a little over the time, right? Oh, wait, there's just one question I need to do. Because the last two is for homework. Okay, yeah, great. Let's see how fast we can finish this. Sorry. So this question is May 2018. So can I erase this?
Yep.
Yes, sir.
Okay. Okay, let's see this question. It says here that anybody want to share the answer first? Anybody? Hello, anybody want to share the answer?
The May 2018 question 10.
Yeah.
So that real confusing. I don't know if I just tired and I get confused, but it confused me.
Oh wow, I'm not watching it. It is confusing. This is real craziness, boy. Okay. So AB is equal to M, DC is equal to 3M, and AD is equal to N. Okay. Complete this statement below on the geometric properties of the following vectors: A, B, and D, C. Okay, we can see that A, B, and D, C are multiples, right, of each other, because DC is 3 times the value of AB. So that means that AB is 3 times CD. I don't think it's that easy. Something wrong. I highly doubt that's so easy.
Isn't it AB and DC are parallel, and AB is 1/3 times CD? That's it.
CD, yeah, correct. But it's not CD, it's DC. Yeah, that is correct.
Basically, that'll be minus 1/3 of CD.
Minus 1/3. Nah, just normal 1/3.
Okay.
Yeah, that's actually correct. And express BC in terms of M and N. So, okay, let me just write the answer for you all then. You want to repeat the answer so I can write it down?
Sure. AB and DC are parallel.
AB and DC are parallel.
And AB, well, back to AB is 1/3 times CD. Or 1/3 times CD.
DC.
DC, yeah.
But to make it, instead of having to say, because this will make it negative, we could just find the absolute value.
Okay.
So let me just rephrase this statement now, because we have to write it in a statement form. So the statement form will be AB and DC are, let me just see, A, B, and DC, they are parallel, which is what we have here, right? And we can safely say that also AB is 1/3 times CD or DC, it don't matter. Oh, actually it does, they give us what they want. So this is our answers here, right? Parallel and 1/3. So anybody else got that? Why negative? Where you see negative, Johnson?
That was from the part B of number 11 in Jan 2018, but never mind.
Oh, okay, all right, no problem. So let's see the other part. We have to state, we have to express B, C in terms of M and N. Excuse my handwriting, I really want to just end the class, so sorry. express BC in terms of n. Okay, so if we want to find BC, okay, based on the triangular law, sorry, we start with B and with C. So in between there, we will have A and of course A. So since we weren't given BA, but rather AB, it will be, and AB is M. If we find BA, it will be negative M plus AC. But what we given AC? What we given AC, people? No. So to find AC now, we have to find AC. So to find AC, I'll do that on the top here somewhere. I'll just erase this here, right? We wouldn't give an AC. So we have to find AC now. AC, we know we're starting with A, we ending with C, and have D in the middle. So AD and DC. Okay? And AD is N, and DC is 3M. So AC is really, so it's minus M plus what is AC, which is N plus 3M. So this will work out. The M will cancel with one of this M here. So our final answer, sorry for writing it so jumbled, it will be N plus 2M as our final answer. Any questions so far? Well, any questions at all?
No, sir.
And that was it then?
Yeah, the rest is homework.
Okay, great. So yeah, that's it. And that's the end of class today. Goodbye, everybody. Be safe. I'll see you all back tomorrow morning for those of you who have class in the morning.
Yes, sir.
Okay, goodbye.
Bye, sir.
Bye, sir.
Have a good day.
You too, everybody. Bye.